as we now go back and look at a review of U-Substitution. And it says this is from section 10.2. So these are the corrective assignments. You may not have done the corrective assignments, which is why I chose these to look at. I mean, we did the notes and we did the practice problems, but these are now the corrective assignments that went with that. So section 10.2, this is back to the flip math people, if you want to see their video too. All right, so U-Substitution. Reverses the chain rule. That's important to us. By the way, can you think of when we use integrals? This whole section is on techniques of integration. This whole unit is techniques of integration. When do you need to integrate? When is integration important in the real world? Ooh, tough question. Can you tell me?
When you know how fast something's going, but you want to figure out the position of something.
Okay, when you know how fast something is going and you want to figure out the position, because remember integrals are like going backwards on those types of things. Very good. Volume, right. That's what I was thinking of, Olivia. The volume and finding the area of something, that whole unit we just did with solids of revolution, they were all integration things. We were integrating the whole time. And when you're integrating, think about the volume. When we revolved something, what's a real world application of those revolutions?
Building a building.
Building a building, like when you do a CAD drawing of something, right? CAD drawings have to be 3D. So you've got to have that three-dimensional thing coming into play. That's integration. That's all that stuff that we did. And I think of like medical testing, when you have like an MRI done or something like that, or something where they're looking at the 3D version of your heart or whatever it might be. You know, that's important. Somebody who ever developed that software for those programs had to have known calculus to be able to do it. So there are the integration. Right now we're in the weeds of methods to find integrals, but really there are bigger applications for it out there. Okay, so not that you would remember, but there is an integration by U-Substitution. Something's got to be U that you're substituting in there. So you have to decide, you're ringing a bell, right? Something's got to be the U. Well, the U is usually the ugliest thing. So I kind of look at this and I'm looking for ugly. Any guesses as to what you would make your U?
The x squared plus 3.
Right. Whatever in the parentheses is a clue. Yeah, x squared plus 3. Then what you're going to do is you're going to take the derivative of it. You want to know what du is. All right, well, du would be x squared, so it's a 2x, dx. Don't forget the dx. And then you go back and you look at the original equation and you're going to line this up. You want to make sure that you've got the pieces in the right places. I have an x and a dx. I don't have a 2. This 2's got to go. All right, so the 2, I'm going to divide both sides by 2. I'm going to make this 1/2 du, or du over 2, equals x dx. And the goal is to set this up so that when I do the substitution, everything can kind of fit together. So that's what I'm going to try next. And by the way, these first ones are without bounds. So I'm going to ask you in a few minutes how that affects my answer, but we're not there yet. Okay, so just giving you let you think about it for a minute. So here's my substitution. There's guesses in the classroom, but we're not saying yet. Okay, so I'm setting up my integral with my substitution. I have u being raised to the 5th power. And then the x and the dx are represented by 1/2 of du. Now I'm kind of quick on that. You catching what I'm talking about? Because we did really see these before. Okay. So I'm going to take the 1/2. He's in a bad spot. He can come out. He's a constant. So he's coming outside. 1/2 u to the 5th du. I'm cleaning it up so I can then take the integral. So integral rules say, all right, take it to 1 more power, divide by the power. So I have a 1/2. I'm going to have a u to the 6th over 6. You can make that 1/6 if you want. And then I just put my answer together. This one's going to be u to the 6th over 12. And then my first question is, am I done? No, my friend Sairaj says. Oh, Olivia put it up there. She put it up there. All right, so first thing, before I put the plus C, and you are correct about the plus C. That was the question I was asking earlier. All right, got to take what U is. Yeah, that sounds like bad English, but got to be what U is. All right, here it goes. I am 1/12, and I am an x squared plus 3 to the 6th power plus C, and that, my friends, is the integral using U-substitution. All right, how about number 2? I've got to decide what I want to make my U, and you're all crying already because you're seeing the trig functions. All right, which one's in a messier spot? Cosine's in a messier spot, right? He's being cubed. So the power on the cosine is a cube. It's to the 3rd power. So it's sine of x is the integral of the sine of x cosine cubed x. The messier part is the cubed part, so that's going to be my cosine. My cosine's my u. All right, before I make my substitutions, what's du? What's the derivative of cosine?
Sine.
It is sine. Anything else? Negative sine, Abby says. She's right. Go, Abby. Well, I'm looking at my substitution here. I have a sine of x. I have a dx. I don't have the negative. He's going to flip over to the other side. And this will be a negative du that is equal to the sine of x dx. And then I think I'm ready to do my substitution. Right? So if I put it together, I have the sine of x dx, that's this piece and this piece, that equals a negative du. And then I have a cosine, well that's my u that's being cubed. Now that looks funky. I don't have that in the right order, so I'm going to clean it up. First thing to do to clean it up is take the negative out. And then I have a u cubed du. And that's easier for me to take an integral of. All right, so you take the integral and I'll take the integral and we'll see if we match. See if you can write the answer out. Okay, are we in agreement? Negative 1/4 cosine to the 4th plus c?
Is it more right to write it negative 1/4 as opposed to cosine over 4?
So the question in the classroom, it's a great question, is it better to write it as a negative 1/4 cosine to the 4th, or can you write it as negative cosine to the 4th over 4 instead of putting the 1/4 in front? And the answers there both equally the same, and Mr. AP appreciates it either way equally. So yeah, it doesn't matter which way you want to put it. All right, folks at home, good with that? Because I want to take one more. I'm not done with that question yet. Because here's my next question. How about if I wanted to check my answer? Ooh, huh. How about if I wanted to check my answer? How would I do that?
Did you take the derivative?
The guess in the classroom from Seal is that I'd take the derivative of it, and she's correct. Let's try that. Try taking the derivative of that thing. Ooh. Oh, I'm asking a lot. I'll give you a head start and then I'll talk.
Yep, that's it.
Did you get it right?
Mm-hmm. 4 comes down.
Yep. Hold on, Sairaj. Hold your horses. Tell me in a minute. Don't forget with the chain rule, you've got to take the derivative of what's inside. Ah. All right, so Sairaj, tell me what you did.
Okay. So like I brought the 4 down, cancel out the 1/4. The derivative cosine is negative sine. So you cancel out the negative with that. You just end up with sine times cosine. You want me to slow it down?
No, no. No, I'm trying to take where you're at here. And then this would be a negative.
The 1/4.
Mm-hmm.
Leave the negative, and then it'll be a negative sine of x.
All right, and then if I have my negatives cancel each other out, so now I'm at a sine of x, cosine cubed of x, and there I am, back where I was. Yep. So for all of these, you can check yourself is what the point is. Very good. Okay, pick me one more from, actually, take a look on the next page, too. Anything else from 3 to 10? Pick me something ugly. I think I know the one you're going to pick.
Number 7.
I don't like 9.
Number 7, number 9. Actually, to be honest, number 7 comes out pretty nice. Let me give you a clue on 7. Number 7, take the uglier grouping. The uglier grouping is the larger powered one, especially it's being cubed. So your u for number 7 is going to be 2x cubed minus x. And then nice enough, it comes out to be a du of 6x squared minus 1. So 7's not as bad as you think it is. I'm hearing 9s. I was hearing 9s in the hood, I think. Let's look at 9. Number 9, I have an ln of x that's being square rooted, and I have an x, and my decision has to be, what is your u? So who's in an ugly spot? The ln of x is in a bad spot. He's in that little square root. Right, so ln of x is going to be your u. Good. Watch what that makes your du. Oh, look at that. 1 over x dx. Do you have that? Yes, you do. Right? Not as bad as you thought, but let's finish it since we started it. All right, so I'm ready to just do the u sub on this. I'm ready. Here it goes. I've got u being raised to the 1/2 power. That's my square root. And du is my 1 over x dx, so this is just times du. All right, I'm ready. I don't have to clean it up or nothing. You would think that's so complicated, and it turns out to be so pretty. Okay, so I'm adding a power on, u to the 3/2, and I'm dividing by that power of 3/2. Remember how that changes it to a 2/3. So my final answer is going to be 2/3 of the ln of x, my u, to the 3/2 power plus a c. All right, the last one like this we're going to do, because then I want to show you how it works with bounds. That's the second page. I want to look at the number 8. I think number 8 might make you crazy. All right, so number 8, back to trig functions, right? We know like trig functions. Well, I have a secant of 5x and a tangent of 5x, and my decision has to be what's u. Now, interestingly enough, the u is just the 5x. It's not the trig function, which is why I think this might have given you some funkiness here. Because if you think back to your derivative rules, remember one of them is secant tangent? Ooh, right? So you don't want to you don't want to break that up. So if you use just the angle being 5x, then du is 5 dx. And you have the dx, you don't have the 5, so swing him to the other side. He's going to be a 1/5 du is your dx. So that when you do the U-substitution now, it's not going to look pretty for a minute, but it'll get pretty in a couple minutes. You'll have the secant of u, tangent of u, times 1/5 du. And so make it pretty so you can do your antiderivative. Take the 1/5 out. Secant of u, tangent of u, du. And then you've got to think, oh my goodness, whose trig? Now, can you remember without going to your cards? I don't know. Any guesses in the hood as to what the integral of secant u, tangent u? In other words, whose derivative is secant u, tangent u? Oh, good guess. Tangent, cotangent? No. Tangent would have been my guess too if I was a wrong guesser.
Well, secant.
Tangent is secant squared, right? Cotangent, I think, is cos. Yes, it's secant. It is secant. You can check your cards to make sure, but yeah, it's really secant. The derivative of secant is secant tangent. Is that a new trig function, Olivia? I like it. That needs to go on our. It's my fave. And we need to have the word wall, right? Just make it a word wall for everybody, because that one should be up there. I love it. Okay, anyway, to finish this out, final answer is 1/5 the secant of 5x and then a plus c. All right, so that one was kind of unusual because the u that you, by the way, you know you picked the right u and you know you didn't pick the right u when you can't do the right substitution, right? When it flows together and you're like, yeah, I got this, like everything's accounted for, you know you picked the right u. There are times when you pick the wrong u and things won't line up and you need to go back and pick a different u. Okay, so that does happen.
Like, I saw number 3 on the answer key and it looked pretty messy.
1 second. 1 second, Sarge. By chance, did you ask about the...
I did. I haven't heard back yet.
Oh, thank
The
you.
document down, right?
Yes.
Yes.
Thank you.
You're welcome.
Okay, Saraj, go ahead.
Number 3 on this packet looks a little bit messy. Like,
Number
I don't know where the L and
3. I'm looking. It's here's what it is. Let me look at number 3 with you. I got it. I see what you're saying to me, and I think you're forgetting one of the. Hey, I'm sorry. Say again. Yes, it's our part of the building. Yeah, we're having loveliness. Our internet's moving slow today. Okay, let me show you number 3. This was a question, and it's a good question because you get to a stuck place on this one. All right, so the part that you're going to pick for your u is obviously the denominator, right? That's the messiest thing here. I have an x squared minus an x plus a 5. My du is a 2x minus 1. Ooh, check that out. Nice, right? I feel like slope dude. Nice, negative. Okay, so that part is my du. But if I look at this for putting this together, it's 1 over u and then du. I can hear the light bulb going on. I heard it. Yeah, if you take the integral of a 1 over u, it's ln. Right? Because what's the derivative of ln? 1 over x. Okay. So this one becomes, when I take the integral, it becomes the ln of u, or in our case, the ln of x squared, not 2, of x squared minus x plus 5. But remember, ln's have to always be positive, so the way that they adjust that is just putting absolute values on that. It has to be a positive value. So it's kind of added in little doodaddy that you need to remember. Yes. Yeah, once you see that, I could see you getting to this place and going, ooh, yeah. But once you see it, it's not that bad. All right, let's try a couple with bounds. By the way, the answers to all of these are at the bottom of the page, on the second page for these first 10. Let's go to the second page and try a couple with bounds. And again, I think the answers are at the end as well for this. And I think now that you kind of got your momentum going with this, you might remember what we need to do about the bounds. We've seen ones like 1 and 2, kind of 3. How about, let's try 4. Does 4 look a little ugly? I want to try the uglier ones, right? We'll start with 4. Well, you do exactly the same thing you just were doing, right? You got to figure out what the u is. And my u, in this case, guesses? Anybody?
1 minus x.
1 minus x, great. It's whatever that power is. Right, good thinking. So it's 1 minus x. That makes my du a negative 1 dx. I don't have the negative, so I'm going to make it a negative du equals my dx. Now I kind of did that a little bit fast. Does that make sense? Okay, so let me do the substitution in here. I'm going to have my integral. I'm not putting bounds on it yet. Hold on for that, Nelly. All right, I'm putting in e to the u with a negative du, so it's going to be times du. I'm going to toss the negative out in front. Now that we've gotten the hang of it, you got it. But the deal is I've got different bounds, right? My bounds have changed, and the bounds have changed in regards to this equation right here.
Don't you put on n and then you get the new one?
You need your u bounds. You need the u bounds, not the x bounds. So I need to take this thing and I need to change it up. So my first bound, if x is 2, u equals 1 minus 2. So my new upper bound is a negative 1. And my new lower bound is 1 minus 1, or 0.
Then aren't they,
But then the question comes up and you're looking at this going, wait a minute, they're backwards, right? Oh man, if I look at my numbers, the smaller number should be on the bottom and the bigger number should be on the top, and they're not. Did I do my math wrong? Nope. Did my math right. So if I want to switch those bounds and put them in the order, I'm off screen, okay. And put them in the order they're supposed to be, I'm flipping them. All right, well that's a legal math move. I'm going negative 1 to 0, provided that I make a negative in my integral. But I already have a negative out there. Now they become positive, and I'm like golden. Flip and take away the negative. Very good, Olivia. Okay. So let's finish it out. What is the integral of an e to the u? And you say e to the u. It would be times the derivative of u, which is a 1. And I'm going between negative 1 and 0, so I can literally evaluate this one. It's going to be e to the 0 minus e to the negative 1. And if I think e to the 0, anything to the 0 is 1. E to the negative 1, you can leave it as e to the negative 1. You can put it as 1 over e. I think they put it as 1 over e. Same thing. Doesn't matter. Ooh, off the screen. Do I need a plus c? I do not need a plus c because I have an actual answer. Cool. Questions on that? So pick me another one that looks bad on this problem set from 1 to 6.
Either 5 or 6.
Either 5 or 6 is what the classroom's saying.
Yeah.
I'm looking at those two. I think that 6 is the trickier one because you have to evaluate some of these trig functions to get the bound. So let's go with 6. Probably this will be our last one. Obviously this one's a lot like the one that we did a few minutes ago, but see how now I have a trig function that's being squared? This time I'm not going to just use the 2x, because in the last problem it was just a secant and a tangent. That was fine. This time the secant is actually being squared, which means my u is going to be the secant of 2x. And you'll see how this flows in just a second. That means my du is, what's the derivative of secant? Secant tangent, right? We just kind of saw that in that other question. Secant, keep it 2x, tangent of 2x. Chain rule says times the derivative of the angle with respect to x. Now I can kind of see how this thing's going to develop here. I have a secant and a tangent. I don't have the 2. So the 2's got to go to the other side, and that's going to be a 1/2 du equals a secant of 2x, tangent of 2x dx. Let's take our integral and set it up, see how it flows. The secant of x and the tangent of 2, the secant of 2x, tangent of 2x, and dx are all included in my 1/2 du. And then what am I left with? A u. Right, just a u. Exactly right. I'm left with just a u. So as I clean this thing up, it's going to be the 1/2 on the outside, the integral of u du. And so then I want to figure out my new bounds, right? So my equation comes from this, got this guy right here. So my upper bound is a pi over 8. My new bound is going to be the u equals the secant of 2 times pi over 8. Well, that would be the same thing as the secant of pi over 4. Ugh. So I go to the unit circle and I think, all right, well, what's pi over 4? Well, pi over 4, I'm going to come over here, is the square root of 2 over 2, square root of 2 over 2.
Don't you just flip it and
Then you flip it, okay? So you're flipping, it's really the x value. Not that it matters because they're both the same, so even if you got that wrong, you got the right thing. So flip it is 2 over the square root of 2, and you say, no, 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 rationalize that guy. Square root of 2 over square root of 2 gives me my square root of 2's, I get 2 square roots of 2 over 2, gives me just a square root of 2. Woo! This equals a square root of 2. And then my other bound is the secant of 0. 2 times 0. Now if I'm at 0, then my coordinate is 1, 0. Secant would be the flip of the x. If I flip a 1, I get a 1. So it's just a 1. There are my bounds. Square root of 2 on top, 1 on the bottom. All right. I'm right here looking at this setup, and I'm going to f of b minus f of a when I get my integral there. So I have 1/2. What's the integral of u? U to the 1 more power squared divided by 2. So it's going to be either 1/2 or put it over 2 if you like. 1/2 of u squared. 1 more power divided by 2. And that is going between 1 and the square root of 2. Well, I can pull this 1/2, bring it out with the other 1/2. Now I've got 1/4 of u squared going between 1 and the square root of 2. I've gone this far, I might as well finish it out by hand, right? If I've got 1/4, the square root of 2 squared is 2. 1 squared is 1. 2 minus 1 is 1. 1 times 1/4 is 1/4. Did we get it right? Number 6? Yes, we did. Okay? So U-substitution. Just a quick review of what that was, because we're going to need that in the midst of where we're going with by parts. So your task is to complete the rest of the problems that we did not do on these pages. The answers are at the bottom of the page, so you'll know if you got them right or not. And they are due for Sunday. And then we'll start 7-2 on Monday when I see you again. Okay? So these questions on the, as Kat would say, the 7.15 or 1.57, I don't know, whatever that was, are due for Sunday. Questions or issues from my children? Thumbs up, I'm seeing. Okay. All right. Have a great weekend, and I will see you Monday. And my girls here, you guys got to mop down your desks, I think.
Yeah, it's what?
Hey, sir.
10:09 or 10:13?
Say again?
Is this period over at 10:09?
I think in 09, I think. Yes. Oh, Sairaj left. I thought he was saying...
I thought he was asking a
Me
question.
too. I thought so too.